Hello friends, myself Nikita Gagre. I am from Guru Gobind Singh Polytechnic. Today I am going to present a presentation of industrial AC machine. So let's start with course outcome. The first course outcome is use the relevant three-phase induction motor for different application. Use the relevant three-phase induction motor in different application. Use the relevant three-phase alternator for different load condition. Use suitable synchronous motor in different application, and last one is use suitable frictional HP motor for different application. In this course we have to learn various uh, application of three phase single phase motor, then three phase alternator, then synchronous motor and its different types, and then HP motor and its different types. So let's start. Then first of all we have to see the topics which we can learn today. The working principle of production of rotating magnetic field, then synchronous speed, then rotor speed and slip, constructional details of three phase induction motor. In three phase induction motor there are two types: squirrel cage induction motor and slip ring induction motor. The working principle of rotating magnetic field. The rotating magnetic field is produced by the three-phase current of starter and the actual three-phase induction motor. The principle of rotating magnetic field is produced when there is three-phase current of starter actually at the induction motor. It can be replaced by permanent magnet in a permanent magnet synchronous motor. The three-phase winding of the inner starter are spaced 120 electrical degree apart. Means the inner winding is placed at 120 degree apart from each other of rotating magnetic field. Then working principle of synchronous speed. The principle of operation of synchronous motor can be understood by considering the starter winding can be connected to the three-phase alternator supply. Means the principle of synchronous motor is understand when we know the synchronous motor starter winding is connected at the start of the three-phase alternating current. If the rotor speed is made equal to that of the starter field and there is no load torque, this two magnetic field will tend to align with each other. Means the when there is no load torque condition, then these two magnetic field are tends to align with each other. Then squirrel cage induction motor construction. Here we can see the construction of squirrel cage induction motor. Parts that are required for the construction of squirrel cage induction motor are starter, rotor, fan, bearing. Means there are four main types of squirrel cage induction motor are starter, rotor, fan and bearing. The starter consists of mechanical and electrical 120 degree part 3 phase winding with metal housing and core. The core winding are placed at 120 degree from each other and it's winding with the metal housing core. In order to provide the path of low reactance for flux generated by AC current, the winding is mounted on the laminated iron core. The winding of squirrel cage induction motor are mounted on the laminated iron core. Then working principle of slip ring induction motor. This motor run on the principle of Faraday's law of electromagnetic induction. We know the Faraday's law of electromagnetic induction. Whenever the conductor move, it cuts the magnetic field and EMF is induced. We know that Faraday's law. Then EMF induced in the conductor. This principle is applied here when a starter winding is exacted with an AC supply. The starter winding is produce magnetic field. Based on Faraday's law of electromagnetic induction, the rotor winding is induced and generate a current of magnetic flux. This induced EMF develop torque that enable the rotor to rotate. Means here the rotor rotates and it cuts the magnetic flux and it's generated the magnetic flux and the EMF is developed in the torque. Then rotor speed and slip. This rotor rotate at speed less than starter rotating magnetic field or synchronous speed. When rotor speed increase, the slip decrease. Increasing the slip increase induce motor current, which in turn increase rotor current, resulting in higher torque for increase the load demand. Means when the when the speed increase, means when the rotor speed is increased, then slip decrease, and when the slip is increased, induce motor current, and then it increase the rotor current. The result of these increase and decreasing for high torque is for increasing load demand. Thank you. Please like my video.